Alright, so for this problem we are trying to count how many different permutation or arrangement can we make out of 11 sweaters, right? Keeping in mind that we have 5 pink sweaters, 4 white and 2 black, and as well that the colors, alright, we cannot make a distinct difference between two sweaters only by the color, right? So the two sweaters are identical if they have the same colors, right? So before starting this problem, I'm gonna try to jump to a review for the formula. So this is your formula, and what's the formula saying here? If we have n items, all right, so n items, from these items, I mean, they are reparted into n1 identical items, n2 identical items, and nk identical items. So the meaning of this, so we have n1 here, n1 identical items. We have another set which is n2 identical items, and so forth, right, all the way to nk, all right, identical items. So here the only thing that the sum of all these items is going to be total to n, so which means that n1 plus n2 plus all the way to nk is going to be equals to n. All right, so the number of different way that we can different arrangement, right, or different permutation. Remember, two items are identical if n1 and n1 they are the same from the same group, so from n1 or from n2 and so forth. So the formula is like this, right? So this is your formula, right? So it is n factorial divided by n1 factorial times n2 factorial times all the way to nk factorial. So I'm going to try to illustrate this problem here, right? How many different words can we make out of Google, all right, the letters in Google, all right? So this comes nicely because at first we can see there are different shapes and different colors, right? So we can consider like G here is G1 and G here is G2, so they are two different letters, right, at the beginning. And the same thing for O's, right? One red and one yellow, I can consider that's O1 and this is O2, right? I don't really need to do the same thing with L and E as they are only unique. So now what I can consider, I can consider N1 is the letter of G, right? So first of all, how many different words can I make out of this? And that's going to be number of permutations, right? So I can permutate these numbers, right? And number of permutation of these 6 letters is going to be 6 factorial. So now, knowing that the G's are the same and they pronounce the same in the alphabet, so it doesn't matter if the G is here or the G is here. If I switch them around, they will be the same. The same thing here, if I switch the O and O, for example, in this, it will be, doesn't matter if it is O2 first or O1 first, right? So it will be the same word. It does make sense? So then I have to divide by the repetitions. So here the N1 will be considered, all right? The two, so N1 will be the capital G and the G here, that's N1. N2 here will be considered the red O, which is O1, and the yellow O. The N3 will be considered the L, all right? So that's the L, and N4 will be considered the E, all right? So we have 6 letters in total, all right? So if I add N1, N2, N3, all of them here, you're gonna come up to 6, right? So now I'm gonna divide by 2 factorial and 2 factorial and 1 factorial and 1 factorial. Knowing that 1 factorial is 1, so it is pointless to put this 2, right? So whenever is repetition 1 is pointless. So, but this is the formula what is telling you. So it can be 6 factorial divided by 2 factorial and 2 factorial. Probably I can do this. So 6 factorial is going to be 6 times 5 times 4 times 3 times 2 times 1. And 2 factorial is going to be 2 times 2, right? 2 times 1, 2 times 1. So I can simplify probably Okay, so what's going to be this 2 and 2 and 4? So you're going to be 6 times 6, 36 times 5. And I have no idea, 36 times 5 is going to be 180. All right. I could use the calculator, by the way, right? So now I think we are ready to go back to the problem. And if we apply here, so we can consider the N1 equals to 5, the 5 pink sweaters. The N2 here is going to be 4, the white sweaters. And N3 is going to be 2, the black sweaters, right? And if you add them all up, that's the N, it's going to be 11, all right? And the number of different arrangement that we can do, all right, they're going to be 11 factorial divided by 5 factorial times 4 factorial times 2 factorial, all right? And well, I did it by hand last time, so I don't agree by doing this by hand, so let me show you how to do it on the calculator. All right, so what we have here, so first of all, let me show you how you go to the factorial. You go to math, you go to probability, so you see it here, so you're gonna go on the right, probability, and then you see factorial is number 4, all right? So that's how you get to the factorial, all right? Now you need to type the number first, so let's try to type this. So I'm gonna type 11, and then I'm gonna go math, and then I can go to probability through the left instead of right, so one step here, and then I'm gonna go down to 4 and enter. So that's 11 factorial, and then I'm gonna divide, open the parentheses. So you have to open the parentheses, please, here, right? So you're gonna do the same thing, 5 math left down to 4, enter, times 4 right now, math left, and go to number 4, enter, and then times, and you're gonna do 2 math, you go left again, go down to 4 and enter, and then close the parentheses and let the calculator deal with all the simplifications. Please don't do it by hand. All right, so we get 6,930, and this should be your answer. All right, so before finishing this problem, probably let me verify the other one, the one that I did here. All right, so let me do it again. It will serve as an exercise, so you can be 6 math left, go to 4, enter, divide by, open the parentheses, 2 factorial and 2 factorial. Well, I'm gonna put 4 right away, all right, and enter, and that's 180. Okay, good, I'm happy. All right, so, and that's all. I hope that will help.